Hello everyone. Welcome to today's episode of the C Unraveled series. Today you are going to learn about binary search, which is a little bit delayed topic because I started teaching you about bubble sort, which would be used in today's program, as I said in the previous video. So first let's begin with creating the file, which I'll name binary search.c. Not binary, it's binary. Okay, so as always, first things include stdio.h, then the main program, which is int main, and return the 0. If in case this is the first episode you are watching and you want to learn the complete C Unravel, like complete C language, just check out the videos in the description, or you can simply click on the playlist, which would be, I would put it at the end screen, so you can understand everything properly, because most of the things are a little bit intermediate level and are based on the previous videos. So first I'll declare the variables, which is int c, first, last, middle, n, search, and array, which I'll give 100 value. Now I would be printing a statement for the user. Enter the number of elements for the array. We are simply asking how many elements are required inside the array, and I'll give this value to n. Okay, so number of elements has been done. Now you'll be making a for loop because to enter a value inside an array you always need a loop. Also put n here and c. Now again scanf. I'll give a print statement before it. Just wait a little bit because I forgot to give the print statement. Array n, not n, c. I'll also give a print statement here. So this print statement simply asks enter the elements of the array. So we are simply asking that whatever elements you want in the array should be given now. Okay, wait, I forgot. Always remember to put semicolon. Like I forgot, and if I would have run this program, it would have shown garbage value, which would have made me wonder what happened, to be honest. Now obviously it's a search program, so we have to also give it some input that what number has to be searched. So enter the number for search, and now again a scanf, which will again have percentage d. Percentage d is the type specifier for integers. Okay, so this was only the input that we are going to get from the user. Now it's time for the processing. So we'll begin with while loop. First we'll say if the first value is less than or equal to the last value. Wait, we have to give some values. Let me do that first. So the first is going to be 0. Okay. The last is going to be n minus 1. And the middle is going to be the average position. Okay, so it's going to be first plus last divided by 2. These are the values. Okay, now you can see there isn't a red line below first or last. Now we would be using an if statement. Okay, and in the if statement we'll write array middle less than search value, as the binary search runs on the principle of using a sorted array. That's why I also taught you sorting algorithm, which is known as bubble sort, in the last video. We would be later on using it. For now I'm showing you the simpler program. Okay, so now we would be writing first is equal to middle plus 1. We are simply saying if the array middle value is lower than the search value, obviously then the search value would be ahead in the array. So we have to convert the first element ahead of the middle one as the first element. So we would be considering half the array then. Okay, so enter else if, which is further giving a condition, which is array middle equal to search. As a fact, here we are not giving a value to the array middle. We are comparing the value of the array middle to the search value, and we are saying if it is same, then what it has to do is printf %d found at location %d dot comma search comma middle plus 1. You would be wondering, why am I writing middle plus 1 here? The reason is middle is showing the value for the index of the array. Like each element has an individual index inside an array, and that index begins from 0, but obviously locations begin from 1. So we have to do a plus 1 to get to the exact location for the user, and then simply break. Now the next thing is else statement. And in the else statement we would be writing last is equal to middle minus 1. We only got one more condition, simply. Like we have given that what if the array middle is less than search, then we would be considering the second half of the array. If the value is same, we have got the answer. And if it is less, like the array middle value is higher than the search value, it would be considering the first half. And that is what we said here. Now simply write middle is equal to first, wait, I had to put parentheses. I by mistake put curly braces. First plus last divided by 2, which we also gave before. Because we would have to recheck what the middle value is. That is why we had to do this. Now we would again be giving an if value, which is first is greater than last value. As I said, it has to check a sorted array. It can't work on an unsorted array. So we are giving the condition that if the first value is greater than last value, obviously then it isn't sorted, because sorted arrays are always in an ascending order. But if the first is bigger than last, then it's a descending order and it is considered unsorted. So what it has to do is printf not found. We can leave it here, or we can further continue as %d isn't present in the array, or you can also write isn't present in the list, comma search and semicolon. Okay, so that's the program. Let's save it and let me show you. GCC binary search dot c. Okay, I by mistake put a space between them. /a .exe. Now I'll write 5. Wait, I have a mistake there. I'll correct it before I forget correcting it. It would be shown in the next run. Okay, so 10, 20, 30, 40, 50. Okay, that's the 5 values I'm giving. Now suppose I search for 30. It will give the answer 3. Wait, there seems to be a problem somewhere. There is a minute prompt somewhere that it isn't printing. Let me see where it is. Let's once go in the debug console. No, there isn't any need. Let me save it and let me rerun it. GCC binary search, this 5, 10, 20, 30, 40, 50. And if I write 30, there is some problem with the while loop only. You'll surely see it once that what the problem is. First of all, I think I should do this. Tab. Ow. Tab. Save. And now let's check again. Five, 10, 20, 30, 40, 50. 30. B. B. Let's save it. Yeah, now the code is correct. Like it also works without curly braces, but sometimes there are problems in the code, such as this one, that mostly work, but in some exceptional case it doesn't. What is the problem? Maybe declaring it down there. Sometimes the errors are pretty weird, so you have to check everything. Ten, 20, 30, 40, 50. Enter the number to search 30. As you can see now, 30 found at location 3. Okay, now if we rerun it, and this time I give an unsorted array, suppose. Okay, so 50, 20, 40, 30, 10. Wait, I had to write 5 here. My bad. 50, 30, 20, 40, 10. And now if I say 10, you can see it is saying not found because simply the first value, which is 50, is greater than last value. To solve this problem, there is a solution called bubble sort. Like there are multiple more sorts, but this is said to be the simplest one. So I would be showing you how to use it. I'll just copy it till here. So let's copy it and let's paste it here before the search one. Okay. Now all we have to do is int b. Instead of bubble, like there would be slight changes, which we obviously have to do. C, and like I have created an entire video on this, so you can simply check it instead of getting confused here that how this works. That's a separate video, that's why I'm not speaking about it here. Array, also instead of C I would be writing B. D. I won't be explaining. I am saying again because it would get a little bit lengthy and I don't want to make the video lengthy anymore because I think it's already quite lengthy. Array, B, again B, even here B, and right here array. Okay, so all the errors according to it are quite a lot solved. Just wait a little bit. Instead of B, like even B would work here, but I would go with C. And okay, and again C, array, and C. It has no error as you can see. Now we'll rerun it. This time I would again be giving an unsorted array. So 50, 30, 20, 40, 10. Now it would first show a sorted form as you can see. Now it is sorted 10, 20, 30, 40, 50. Now if I write 30, like this time I will give 20. It will give the answer. Okay, so the difference is here we have to remove this. Let's save it. Also, I'll just give it a next line because it is currently getting in the exact same line, which doesn't look that impressive to me. Okay, 5. So 50, 30, 20, 40, 10. Again, you can see 10, 20, 30, 40, 50. Enter the number for search, again 20. You can see now it is giving the correct answer. 20 found at location 2. We can do this till literal infinity. I am running it one last time to show you. So this time I'll write 10. 100, 80, 60, 40, 20. Okay, now 10, 90, 70, 50, 30. These are exactly 10 values. Enter. Now I would be writing suppose. Wait, what? There seems to be a slight problem. But never mind. Because it is going to work. So if I go with 30. Okay. My device just lagged because of that big array. Else it would work properly. Okay. So that's it for today's video. Hope to see you in the next one. Till then, bye.